practice question set number 7 here, guys. It says, experiment is performed using this thing that we call a Van de Graaff generator, which if we have a little bit of time, we might pull that out a little bit later today and see what we can do with it here. Metal sphere hangs on a metal thread. Mass of the metal sphere is 2.0 times 10 to the 5, 10 to the negative 5. This is what it looks like, an angle of 78 degrees here. So this thing looks like it's being repelled, right, from the dome of the Van de Graaff generator. It must be repelled, right, because if it was attracted, it would be pulled towards it. So what do we know about this? Well, the metal sphere, the Van de Graaff generator must be like charges, right? Doesn't say, yes, the Van de Graaff generator is positive. The Van de Graaff generator is positive, and that means the metal sphere must be what? It's got to be positive as well. Right now, what's the question? We don't even know what the question is yet, right? We've just noticed a couple of things about this that if we do notice, we might want to write down. If we don't, that's okay. We're skimming it, and then we look at the question in more detail and go back and look at the info then. Number 1, when it touches the generator, the metal sphere becomes what as a result of the transfer of what? All right, so the metal sphere is hanging, and then it touches, and then it's repelled. Well, when it repelled, it must have became positive. We established that, right? So if it was neutral and it became positive, then it must have been due to the transfer of what? Electrons from what to what? Which way did they go? Did the electrons go this way to make the metal sphere positive, or did they go this way to make the metal sphere positive? A or B? It's B, right? If it was neutral and became positive, then it must have lost electrons. So the answer for this would be the metal sphere becomes positive. We know that, otherwise it wouldn't repel. And it becomes positive due to the transfer of electrons from the metal sphere to the Van de Graaff generator dome. Does that make sense? Now, let me just mention something else about this here. This works really, really well because we've got 2 conductors. If we had an insulator here, if this Van de Graaff generator had a massive positive charge and this metal sphere wasn't a metal sphere, rather it was a plastic sphere, you might get electrons transferred, but not nearly as effectively, right? Why wouldn't they be transferred as effectively? Well, because conductors will transfer electrons easier. Does that make sense? Does this become equally positive? Does it balance out? Probably not, actually. Probably wouldn't balance out. You got something that's small, something that's big. They're both going to become positive because they're trying to balance out, but they're probably not going to completely balance out because they're not equal size, equal shape, same material. So it becomes positive, just not as much positive as the other one. Overall, the total charge remains the same. So the answer for that is C. How many people said C? Good. Next one, 3 identical spheres. Here's the charges. What's this mu C thing here? What is that? What does that mean? Yeah, that's microcoulombs. So that's, this in this case would be 4.00 times 10 to the minus 6 coulombs. Not that it really matters in this question. So we're touching one sphere to another, and so on. This is like that table example I gave you, right? We've got sphere 1, sphere 2, sphere 3, and we'll make this the total. We start off as 4, -2, and -4. Add those up, and it gives me -2. Now 1 touches 2. Right? If 1 touches 2, 4 plus -2 is 2. Divided by 2 is +1 and +1. Let's add these up just to make sure. 1, 2, -2. Sure enough, so far. Now it says 2 touches 3. 1 and -4 gives me -3. Divide that by 2, it gives me -1.5 and -1.5. Add those up, gives me -2. Okay, so far so good. Now 1 and 3 touch each other. 1 and -1.5 gives me -0.5. Divide that by 2, it gives me -0.25. And this one is still -1.5. Add these up. Sure enough, it gives me -2. Looks like I've done this right. What's the final charge on sphere 1? -0.25 microcoulombs. Right? How many people got that? Good. So what is it? C is our answer there. Numerical response number 1, the number of excess electrons on this ball is what? We did a question like this Friday, I believe it was. We want to find the number of electrons. We're going to say it's the total charge divided by the charge of 1. So it's negative 3.6 times 10 to the minus 17 coulombs divided by negative 1.6 times 10 to the minus 19 coulombs. That's going to give me a value of 2.25 times 10 to the 2? Is that right? Is that right? Somebody give me a nod here. Yeah, 2.25 times 10 to the 2, which now, I think this is the first time other than our test that we've had to express it this way. If the answer, they asked me to express it as B times 10 to the W, then my answer would be 2.25. If they asked me to express it as A decimal B C times 10 to the D, then my answer would be 2.252. Does that make sense? Not just does it make sense what the answer is, but does it make sense how to express that answer? Okay, I'm going to be honest with you. Lately, the last number of exams, they tend to express it this way, A, B, C, D, rather than the B times 10 to the W. We could be prepared for both, but this is the way it tends to be more often. This is better, right? Because this requires you to also calculate the exponent. If you make a mistake with the exponent, it's wrong this time. Whereas if it's this way, and you make a mistake with the exponent, you get away with it. I think that's why they're leaning more towards the ABCD now. Question?
Why is the 1.6 times 10 to the negative 19 negative?
Why is the 1.6 negative? Because we're talking about electrons.
Right.
And electrons have a negative charge. So in the end, look, the numerator is going to have, in a question like this, the numerator is always going to have the same charge as the denominator, right? If you're talking about the number of electrons, you can't have, it's not going to be a positive number of electrons. Like, it's not going to be a positive numerator if you're talking about the number of electrons. Does that make sense?